Hello everyone, good afternoon. My name is Marco Antonio Rojas and my partner is Mariana Isabel Arreola, and we're going to present you the Integradora project, which is the construction of a solar boiler.
Well, the name of our company is EcoMaster Sustainable Projects. The problematic or Integradora, the heating of water is mainly achieved by burning fuels such as LPG or firewood that mainly affect the environment, as the combustion process gives of carbon dioxide, which is a polluting gas that is guilty of 7 million deaths a year in the world and main actor in the greenhouse effect. In addition, in the first 4 months of the year, the price of this fuel increased by 7.2%, that is 1.09 pesos per kilogram. On a national average, and Durango is the third state with the most expensive gas, being 18.17 per kilogram. In the next graph can show the high price of LP gas in the current year in different states, showing that Durango has the third place in the high cost of gas. General objective: build a heat pump solar boiler with recycled fluorescent lamps to help reducing the emission produced by the natural gas. And specific objectives: the first objective is make a documental researching. Next to design the boiler, select materials, and build the solar boiler. Or problematic: Mexico emits about 435 million tons of CO2 a year, of which 200 million are due to the burning of fossil fuels such as natural gas and gasoline. By implementing solar heaters throughout the country, the emission of 23.8 million tons of CO2 per year will be avoided. Durango is one of the locations with the highest radiation in the world, with an average of 151 watts on meter squared, while the world average is 313 watts on meter squared, which make it the state with great solar potential, which can be used to heat water in clean and sustainable way without the need to burn any fuel. In addition, there are still many fluorines like in operation that will become waste in a short time, most of which will be dumped in a garbage dump without the proper care that should be done and contaminate. Recycled Recycling the tube is a good option to avoid this. Conventional solar heaters use vacuum glass tubes to heat water, as glass is a great thermal conductor and is excellent for this task. Resourcing fluorescent tubes to perform the same function and is a feasible option to prevent them from ending up in a garbage dump, causing even health and pollution problems.
So, well, we're gonna see the theoretical framework of this project, which is the things you should know before you see the prototype. First of all, you need to know all the kind of starter boilers there are in the market, which are the flatted one, which is one of these with a flat surface and the turbine tank, and then the most common ones, the heat pipe ones, which consider in tubes with vacuum um, to make this process of heating water. And then the third one is the concentration system, which is mostly used in industrial processes because this reach higher temperatures until up to 120 degrees Celsius. So this is most used in industrial processes. Then we should know heat transfer. As you know, this thermical machine works with the radiation of the sun. So it receives radiation, which are waves produced by the sun, which produce heat, which is this way of transfer. And then there is also the conduction, which is the most common one, is when you directly put on heat one material and then it gets warmer and warmer until the whole material is conducted until heat. And then convection, this works with the air, the currents of air, they are getting warmer and warmer until they go up because they change densities and they transfer heat from the air. So there's basically three types of heat transfer: conduction, radiation, and convection. I'm gonna explain you the operational work of the heat pipes, which are gonna be used in our prototype. The operational work is basically this one. The sun gives us radiation which comes into the tube, which vacant right here, no air between the tube right here. So the radiation comes directly from to a copper tube, which gets the heat, and right here there's water. So as this is hot, the water gets warmer and gets hot, and by density changes, the hot water goes up and then the cold water stays right here. So this is the simple explanation of how it works. So the cold water goes down, and then when the cold water is heated, goes up by density changes. The design is really important in this thermical machine because it's gonna give you the hot water when there's not sun. So this design made in SketchUp of the exterior tank because there are two tanks involved in a solar boiler. This is the behavior with Iceland. When isolator as polyurethane with 5 centimeters polyurethane as isolator, and with 10 centimeters of polyurethane as isolator, and it can save the heat until 18,000 seconds. So it can like 8 hours of saving the heat. So it's important to be sealed with this isolator, because it's gonna save the hot water that is in the tank. This is the design of the full prototype, which consider in the external tank, and right here in the inside of this tank there's the polyurethane, and then the insider tank which is having the water, and then the tubes right here with the copper tubes, and then the lamp tubes over here. This is the realistic design of it. And this is the thermal tank, the exterior thermal tank, drawed in SketchUp. These were made on SolidWorks. The material for making this prototype was 9 copper tubes with a diameter of 1/2 inch, 9 fluorescent lamps for making the greenhouse effect, and get the copper tube hotter. Then the plastic container, which is going to contain the water, the iron container, which is going to contain the plastic container, and 2 meters of TRP, which is profile made of iron, to make the structure, the general structure of the prototype. The methodology, the process of making it was not easy, but it is possible to make it. First, we add the polyurethane to the exterior of the plastic tank, and then we put it inside of the iron tank to make the holes where the tubes are gonna fit into the tank. And then the structure was made with the profile. Next, one of the most important parts was the sealing the tubes, making these container and sealing it to get it hotter. So we sealed with high temperature glue to not having problems with filtrations of water inside of it. And after this, we put the tubes inside the tank, and we give it the shape it has. And after that, you should add more polyurethane and seal it to don't have any filtration of water. So it has to be sealed perfectly. Well, it took measurements for one day from 10 a.m. to 6 p.m. every half an hour. So we took temperature and radiation, and it gave us this lovely graphic which gave us the highest point. The highest temperature reached was 43.5 at the radiation of 1059.8 watts per square meter. This was the highest temperature reached, which is considered one, it's okay for the purposes that we needed, that is taking a shower. So yes, we think it's a nice temperature. The conclusions, I can conclude that the boiler is efficient because it has the 39% of efficiency, which is not too good, but it's okay for the purpose. The solar boiler reaches the 43.5 Celsius grades, which is okay because the recommended temperature for taking a shower in grown-ups for adults is between 30 and 40 Celsius degrees, so it's okay. Also, if you can, and if you want more temperature, the modifications that we could use, or that we could make, is increasing the incidence area of the solar boiler, which is the copper tubes. We should use with ones with more diameter to increase the isolation and accelerate the process of heating water. So if you change to the 1 inch, you can reach temperatures until 50 or 60 Celsius degrees. And finally, we should be careful with the weather, because as you know, this only works with the sun, and if you don't have it, you should have a really nice thermic tank to keep all this hot water. And we also have to be careful with the mass of water, because if it's too much water, it's going to take longer to heat it at the temperature wanted. And how often do you use it? You have to take care of that, because when you take out the hot water, the cold water is getting in, so the temperature is getting low. So we have to take care of these points. And in conclusion, this project was valued in 2,500 pesos. So we think it's cheaper than conventional solar boilers. So we think it's a good project, and it can help to reduce the emissions of natural gas in the environment. Thank you so much for watching.